Web workers introduce true multithreading to JavaScript. This capability allows for the execution of complex computations in the background, without disrupting the primary user interface thread. By enabling parallel script execution, web workers significantly enhance the performance and responsiveness of web applications. Without web workers, heavy computations block the user interface thread. For example, a function calculating prime numbers in a loop can freeze the interface. On the other hand, with web workers, a dedicated script can run in the background, such as calculating primes, while the main user interface thread remains responsive. There are primarily two types of web workers. The first type is the dedicated worker, which is the standard type, and it runs in the background. It is dedicated to a single script instance and has a one-to-one relationship with the parent page. It cannot access the document object model directly, also called DOM, and it operates within its own isolated thread. The second type is the shared worker. It can be accessed by multiple scripts. This worker facilitates communication between different windows, frames, or even other workers. It uses ports for communication and has a more complex messaging system. To create a basic worker, first, in your main JavaScript file, create a new worker using the new worker constructor and pass the worker script file path. You can then send data to the worker using the postMessage function, along with data and a task. Finally, you can listen for results from the worker using the onMessage event listener. In the worker JavaScript file, listen for messages using self.onMessage. Then, process the data from the event and send back the results using self.postMessage. Communication between the main thread and a worker happens through message passing. The main thread uses postMessage to send data to the worker, and the worker receives this message through its onMessage event. The worker, in turn, can send data back to the main thread also through postMessage, and this is handled through the main thread's onMessage event listener. When passing messages, you can use transferable objects such as array buffer, message port, image bitmap, and off-screen canvas. In addition to that, you can use structured clone for complex data types like date, regular expression, and map. Error handling in web workers involves managing errors that occur both in the main thread and within the worker itself. In the main thread, you can handle worker errors using the onError event listener, which provides information about the error including the message, file name, and line number. Additionally, onMessageError can be used to handle message-related errors. If a fatal error occurs, you may want to terminate the worker with the terminate function. Within the worker, a global error handler can be set using self.onError, and you can also use try and catch blocks within the message handler to catch and handle specific errors. Common error types include runtime errors, network errors, and message serialization errors. Shared workers can be accessed by multiple scripts, allowing communication between different browser windows, frames, or workers. Every tab connects to the same instance of the shared worker. These workers are useful for managing shared states and resources across multiple contexts. For example, multiple tabs connected to a chat application use a shared worker, so that they can share the WebSocket connection and the state between them. To implement shared workers in the client-side JavaScript, create a new shared worker using the new shared worker constructor, passing the worker script file path. You need to explicitly connect to the worker port using worker.port.start, and then you can send messages using postMessage. Also, you can listen for the messages using the onMessage event. In the shared workers JavaScript file, you need to maintain a set of connected ports. Listen for connections using self.onConnect. Each connection event provides a port which you can add to the set and start listening to it. You can receive messages using the onMessage event listener. When a message is received, the worker can broadcast it to all the connected clients. Web workers have several limitations. They cannot access the document object model or DOM directly, meaning they cannot manipulate web page elements. They also lack access to the window object and its methods, such as the alert and confirm functions. Additionally, workers do not have access to global variables or functions from the main thread. Workers do not allow synchronous XML HTTP request calls and lack direct access to the file system API. Therefore, developers must work with these constraints when building applications that utilize web workers. Web workers are ideal for data processing tasks, including handling large datasets, performing complex calculations, and transforming data. They're also useful for real-time processing, such as audio or video tasks. Web workers can be used to perform background synchronization. When using web workers, it's important to optimize the message size by using transferable objects and structured cloning when possible. Always terminate the workers when they are no longer needed. Proper error handling should also be implemented with a fallback mechanism. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.